Okay, so before we can learn about these 95 and 99% confidence intervals, there's something else you need to understand, and that is a point estimate. So what is a point estimate? If I were to say, guess my age, but you can only give me one number. You just have to say, guess my age, one number. You might come up with, oh, I don't know, 29, maybe, 39, 59. Well, I hope not. But you would be giving me one number. So let's just settle on 50. All right. And you might think, well, I have a pretty good chance of being right until you realize one thing. If I am 50.1 years old, you're wrong. If I'm 49.999 years old, you're wrong. I have to be precisely 50 years old. Now, do you think that you have a good chance of being correct? Probably not, right? Because what are the chances that I am exactly 50? But this estimate you gave me is very precise. There was no, well, I think you're between. There was none of that. You said, I am 50. That is super precise. It's also super likely to be wrong. Okay? So a point estimate is, we say it's a point estimate if you give a single value, so one number, and you give me one number, and this is used to estimate the parameter. Well, my true age is not exactly a parameter, but you get the analogy, I think, right? So you give me one x bar. You might say x bar equals 50. Well, that means you have one chance of being correct. There's one chance that the parameter mu is exactly 50. All right? It's called a point estimate. So your x bar equals 50. That's just one number. That's a point estimate. They are very, very specific. In other words, precise and informative, but they are unlikely to be correct. And here, accurate and correct mean the same thing. Be careful because I'm telling you these are the same thing. And a lot of times people confuse accuracy with precision. Okay, please don't do that. Remember, accurate and correct mean the same thing. Precision means something else. If something is precise, that means there's no wiggle room. All right, so if you say I am 50, that is very, very, very precise. Okay? All right. Now, the thing you have to understand is interval estimates. What is an interval estimate? Well, it starts with a point estimate, and then you draw a range of values around that point estimate. So if, for example, you were estimating my age and you said 50, that's a point estimate. But if you said 50 plus or minus 10 years, so in other words, I'm between 40 and 60, then you've given me an interval estimate because now there's a range of values. And as long as my true age is within that range, then you would be correct. All right. So when we draw an interval estimate, like you're saying, I'm going to change this to the mean because that's what we're going to draw intervals around. So if you say the mean is 50 plus or minus 10, then what you're really saying is the true mean, mu, is between 40 and 60. That's kind of like saying my true age is between 40 and 60. Okay. Now, you can see that with this type of estimate, these interval estimates, they have a greater chance of being correct than point estimates have, right? Because now there's many, many different possibilities or many different opportunities to be correct, all right? Not just one. Now, how many depends on the size of the interval, all right? So if you said I am between 40 and 60, well, there's an infinite number of ways here you could be correct as long as it's between 40 and 60. So there's still a possibility that I'm younger than 40 or older than 60. Now, how could you increase the probability of being correct? In other words, accuracy. Remember, those are synonymous. Well, just draw a larger interval. Like, what if you said plus or minus 30? That means I am between 50 minus 30, 20. I am between 20 and 80 years old, right? Plus or minus 30. Well, if that were the case, you would have an excellent chance of being correct, but you would have lost precision, right? Because the bigger this interval gets, the less precise you are. Even 40 to 60 is really not all that precise. 50 was precise, was super precise, but not likely to be accurate. 40 to 60, you lose precision, right? But you've gained accuracy. 20 to 80, I would say, okay, not only are you so vague, you have almost no precision, but you also really have no valuable information. So if somebody were to say to you, hey, I need to meet up with Lynn White, where can I find her? And you say, just go to Walmart, look for somebody between 20 and 80 years old, that's not helpful. Okay, so we got to make sure that if we use an interval estimate, we want to make sure that this interval is not too big. All right, this is 20. The size of the interval is 20. Even that is a little big. Okay, so let's see. With interval or range estimates, that's what they're also called, they are more accurate than a point estimate, but they're less precise. All right. Ideally, we would want to still be, have a high chance of accuracy, like being correct, but still maintain a precise estimate, as precise as we can get. All right. So our goal, if this were a perfect world, is we would want to have a high probability of mu being somewhere within this interval. But the interval size itself, we would want to keep as small as possible.